Hi everybody, welcome back to Calculus 2 by Example. In this video, we're going to be looking at how we could reverse our derivative rules in order to integrate functions and find indefinite integrals. Let's start by finding the derivative of f of x equals the tangent of x squared plus 1. Since we have an inside function, x squared plus 1, and an outside function, tangent, we need to use the chain rule. So let's take the derivative. The derivative of tangent is secant squared. And so we have secant squared of x squared plus 1 because for the chain rule, you take the derivative of the outside function with the inside function remaining the same, but then you multiply that by the derivative of the inside function. And so now we need to take the derivative of x squared plus 1, which is 2x. So the derivative of tangent of x squared plus 1 is secant squared of x squared plus 1 multiplied by the quantity 2x. Now, suppose that we want to find the indefinite integral of a function that looks a lot like that. Suppose we start with g of x equals x times the secant squared of x squared plus 1. So I'm going to find an indefinite integral. We do this by recognizing that what we have inside the integral, the integrand, is almost just like what we had when we took a derivative, but we're missing the 2. So I'm going to put a 2 on the inside and a 1/2 on the outside, because 2 times 1/2 is 1, and so they balance one another out. Okay, you could always multiply by a form of 1. Now the inside looks just like our answer that we had previously when we took a derivative. And so the indefinite integral will be our tangent of x squared plus 1 with the 1/2 out front. And we need to remember our plus c. Okay? And we remember the plus c because the indefinite integral represents all possible antiderivatives, not just a single antiderivative. Okay, so that is how we can reverse our derivative rules in order to find an antiderivative or an indefinite integral. In the next example, in the next video, we're going to look at an initial value problem.